This is lesson 4 of Unit 1, Probability and Chance. Probability is a branch of mathematics concerning the likelihood of events happening or not happening. The chances of an event occurring is represented by a number or a percentage. So you could say the chances of getting a certain illness is 1%, with a 1% chance. You could say the chances of rolling a 5 when you roll a dice is 1 in 6. There's a 1 in 6 chance of rolling a certain number. Or the chances of flipping heads when you flip a coin is 50%. Why is probability useful? It helps you understand the world around you. We'll go over some examples today, but probability is all around us. It helps you understand risks and make informed decisions. So like this graphic here, it's looking at lung cancer risk for different types of people, whether you smoke or you've never smoked before or you're a heavy smoker, whatever. So it helps you understand different risks, and then you can make an informed decision about, let's say, whether or not you want to start smoking. And probability also shows the truth about gambling games and the lottery, which sometimes can be misleading. So what are the chances of winning the lottery? In this graphic here, it's giving some different examples and what the odds of those things occurring are. So the odds of winning the Mega Millions jackpot, I think this is in the States, is 1 in 302,575,350. So pretty small chance. And you can see the other events there are more likely than winning this jackpot, but they actually sound less likely. So the odds of being struck by lightning is only 1 in 14,000. That's way more likely than winning this jackpot. The odds of being attacked by a shark are more likely, and the odds of a woman giving birth to identical quadruplets is way more likely than winning this jackpot. So when you put it that way, it might seem maybe a little less likely that you might win that lottery. And on the side here, I have some other examples listed out. So this is saying the chances of getting killed by lightning is 1 in 2.3 million. The chance of dying after coming into contact with a venomous animal or plant is 1 in about 3.5 million. And then it continues that way. So you can just see that the actual chances of winning the lottery, especially the big jackpots, is very, very small. And so when you compare it this way, you might rethink buying that lottery ticket. How can we calculate probabilities? The actual formula for calculating a probability is the number of possibilities where that event occurs divided by the total number of possibilities. So if we have a basic example when we're rolling a dice, when you're rolling one die, there are 6 possibilities. You could roll the numbers 1 to 6. And so if we're looking for the probability of rolling a 2 with a single die, that would be calculated as taking 1 divided by 6. Because there's only one possibility where we roll a 2. There's only 1 2 on the die. And how many total possibilities are there? 6, because there's 6 sides of the dice. So that means there's a 1 in 6 chance of rolling a 2 when you roll a die. Another example, what is the probability of flipping tails on a coin? So there's only heads or tails on a coin. So that probability would just be 1 in 2, or 1 over 2. Because there's one situation where you flip a tail, and there's 2 possible situations, heads or tails. So we're going to try some practice examples. Let's say you're rolling 2 dice. Maybe you're playing a board game where you have 2 dice. And if you roll both of them and add up the values, maybe that's how far you're going to move on the board, what are the possible sums that you could roll? Okay, well, the lowest that you could roll is if you've got snake eyes, a 1 and a 1. So that would be a total sum of 2. So the lowest you could get is a 2. And then you can get every other sum all the way up to 12. So the highest possible sum you could get would be if you rolled a 6 and a 6, which would get you to 12. So our task is to create a table that shows all these possible sums from 2 to 12 and which pairs or which 2 dice combinations would create that sum. So I have that on this next slide here. I've listed out all the different sums, 2 to 12, and the different pairs of dice that could lead us to that sum. And you'll see that it follows this kind of triangle shape. So the only situation where we roll a 2 is if we roll a 1 and a 1. There's slightly more of a chance that we roll a 3 because we could either roll a 1 and then a 2 or a 2 and then a 1. Those are considered different events because the first dice is different. And as we move along, we see that 7 has a whole lot of possibilities. You could roll a 1 and a 6, a 2 and a 5, a 3 and a 4, or the reverse of each of those options. So there's tons of situations where you would roll a 7. There's very few situations where you would roll a 2 or a 12. So you can see, and then you can also see like 5 has 4 possibilities, and so does 9. So that means the probability of rolling a 5 is the same probability as rolling a 9, because the same number of possible situations where you get that solution, those are the same. So to sum that up, if you're rolling 2 dice, the sum that you're most likely to roll is 7, and the sums that you're least likely to roll would be 2 and 12, because there's the least possible pairs that could get you to that number. Okay, independent events. Events can be either considered independent or dependent. Events are considered independent when their probabilities are not related or connected to each other. So you can think of it as like, if you're an independent person, you don't depend on anyone else, you're self-sufficient, you don't have any like relation to anyone else. So for independent events, one event occurring or not occurring does not change the likelihood of something else happening. So for example, if I roll a 2 in a game, that doesn't change the probability if someone else is going to roll a 2. My roll doesn't affect their roll. At the end of the day, you're just rolling a dice. The dice doesn't know if the person before you had rolled a 2. They're independent events. Every time you roll that dice, it's a clean slate. You could get any number. So that might sound like an obvious explanation, but there's a lot of situations in the real world where people think that they are dependent events and that these two events have probabilities that are connected to each other, when in reality, they are not. And so it's important to understand the difference between events that are independent and events that are dependent, because this can change how you view the world and how you make decisions. So we'll go through a couple examples here and figure out if these are considered independent or dependent events. First one, so the first event is you roll doubles in your first turn. And the second event would be you roll doubles in your second turn. Are these independent or dependent events? In other words, if I roll doubles, does that change the probability that I roll doubles the next time I roll? No, those are independent events. Those are not related to each other. I could roll doubles and the next time also roll doubles, but those have nothing to do with each other. It might be a lucky chance, it might be a coincidence, but they're not related to each other. And that is kind of counterintuitive. If you were playing a board game and you rolled a bunch of doubles in a row, you might think, oh, I'm on a lucky streak. I'm going to get doubles again because it's been happening so much. But that's just confirmation bias. That's just a lucky chance. They are not actually connected to each other. Because in order for them to be connected to each other, as I said before, the dice would have to somehow know that the turn before you had rolled doubles. So now it's going to do it again, which obviously is impossible. Okay, another example. Event number 1, you go for a run tonight. Event number 2, you go for a run tomorrow morning. Are those independent or dependent events? Well, that can depend on the person, but I'm going to say those are dependent events. Those are connected to each other. If you do decide to go for a run tonight, that might affect the probability that you go for a run tomorrow morning, because most likely you're not going to run again if it's like 12 hours later. You're probably done your exercise, maybe you're a bit sore and tired. So those are connected to each other. If you run tonight, you're less likely to run tomorrow morning. Again, depends on the person. Next example, flipping heads 5 times in a row, and then flipping heads on the 6th flip. These are still considered independent events. Even if you've somehow got, in quotes, lucky, and you rolled heads or you flipped heads 5 times in a row, that doesn't mean that you're more or less likely to flip heads on the 6th flip. Every single flip is independent. Next example, you win $5 on a scratch card, and then you go and enter a lottery and you win $100 in that lottery. Were those two events connected? Do their probabilities depend on each other? No, those are independent events. Again, maybe that's a super lucky day. For whatever reason, you won $105, but it's just that. It's just a total fluke. You don't actually have, in quotes, lucky days. Those do not mathematically exist. Just because you won $5 on a scratch card does not mean you have a better chance at winning a more expensive lottery. Okay, next example, drinking a lot of water and having to go to the bathroom. So these are considered dependent events, of course. If you drink more water, that's going to increase the likelihood that you have to go to the bathroom. So these are dependent events. They connect to each other. Doing one thing changes the outcome of the other. And lastly, you might say, like maybe you've never broken a bone, and then the second event would be breaking your arm. Are these connected? Are these independent or dependent events? These are considered independent. So it's not valid to say, oh, well, I've never broken a bone, so it's bound to happen soon. I'm bound to break my arm because I've been lucky enough and it hasn't happened yet. Again, this can depend on the situation and the person, but those are, in most situations, independent events. I've heard, I had a friend say to me one time, oh, I've never gotten a bike accident, so it's bound to happen soon. And I tried to explain to her that that's not valid because those are independent events. Just because you've never gotten a bike accident before doesn't increase or decrease the likelihood that it'll happen the next time you get out on your bike. Okay, the last part of this lesson is about insurance and probability, which might seem unrelated, but insurance payouts are directly tied to probability. And it's another important real world application where it's important to understand probability. So if you're not aware, a quick recap of what insurance is. How this works is you purchase protection from insurance companies to safeguard the cost of expensive items, like your house or car or jewelry. So if these items get damaged, lost, stolen, etc., the insurance company pays you money to replace or fix it. So you pay the insurance company money each month or each year for this agreement, and then you have peace of mind because you know if your house burns down, if your car gets stolen, or whatever happens, you will have the money to replace it and fix it because the insurance company will pay you for that. Because they're saying, I promise it'll be fine if something happens, we will financially take care of it. You just have to pay us each month for this peace of mind and for this agreement. So how is insurance priced? It is different for different people in different situations. There's not just one car insurance price. It's always slightly different because the prices are calculated based off probabilities. So the question they ask is, what is the probability that this person damages their car or their house and needs to claim insurance from us? So if the insurance company thinks you're more likely to claim a payout from them, they will price your insurance higher because they don't want to give you the payout. They want to take your money and never have to give it back to you. So if they think you're higher risk, you're going to pay more. So what factors might make your insurance more or less expensive? We're talking about car insurance, your age and your experience. The younger you are and the less experience you have driving, the more expensive your car insurance is. Because based on statistics and probability and past events, people who are younger with less experience get in more car accidents and pay or claim more for insurance. And that's no fault of your own. It's just you're younger and you haven't driven as much. So you're more likely to get in an accident or to have some damage. The type of car, if you have a sports car that goes super fast, you're going to pay more insurance because you're more likely to get in an accident because you're going fast enough to cause more damage. Depending on the type of car, if you have a really old car, it might be more or less, but it depends on all of those factors of what type of car you have. If it's electric or not. On your driving record, if you have a history of a bunch of accidents, your insurance is going to be way more expensive because you've proven in the past that you are maybe a bad driver. So then they're going to make you pay more for insurance. Crazy enough, your gender or the color of your car can make your insurance more or less expensive. Generally, boys have to pay more for insurance than girls because based on the history and the statistics and the probabilities, men are more likely to get in car accidents than females. And I think it changes the older you get, but I think it's more like teenage boys are the most likely to damage their car, unfortunately. So then they have to pay more in insurance. And even if you, as an individual teenage boy, are a perfect driver and you yourself are not going to get in an accident, it doesn't matter. Because of that characteristic that you have, that type of person or car is more likely to cost this company more, so you have to pay more. It's kind of unfortunate. The color of your car. A red car will cost you more than in insurance than a black car, because based on the statistics, red cars are more likely to get in an accident. And there's all sorts, I could go on forever about all these different characteristics, but all of these, you calculate the probabilities of all of these things and it goes into your full price for your car insurance. And the same is true for house insurance. So do you have an old home or a new home? Is it an apartment or is it a house? Is it downtown in a busy area or is it in a quiet neighborhood? Are there environmental threats nearby? So is it more likely that your house is going to burn down or get destroyed in an earthquake? Is it right by the water? Is there going to be water damage? All of these things go into play when you're figuring out, or when the company's figuring out, how much you have to pay for house insurance. So to end this, we'll talk about, is this pricing method fair? The entire business of insurance is based on probabilities. They calculate the chance of certain events occurring, see how much that would cost them, and price the insurance accordingly. I believe that the pricing method itself is fair because, of course, if events are going to be more likely to cause damage, it should cost more, and vice versa. If you have a perfect driving record and you've never gotten in an accident, then you should pay less for insurance because it's less likely that you're going to cost them any money. But on the other end, sometimes insurance companies hike their prices for no good reason besides greed and wanting more money. And then that's when it can be a bit unfair if insurance prices are really expensive. But I think at its heart, the pricing method itself is fair because it's based on true probabilities. So that's our summary of probabilities and chance, and that's the end of our Unit 1.